Hello and welcome to another video. In this video we're going to be working on minimum length of a string after deleting similar ends. And in the problem you have a string consisting of A, B, and C. You're asked to apply the following operations any number of times. Pick a non-empty prefix from S where all the characters are equal. Pick a non-empty suffix in S where all the characters are equal. The prefix and suffix should not intersect at any index. And the characters from the prefix and suffix must be the same. Delete both the prefix and the suffix. Return the minimum length of S after performing the above operation any number of times, possibly 0. So in this first one, you can't do anything. In the second one, you can get rid of the C. Then you can get rid of the A on both sides. Then you can get rid of the B on both sides. And you can get rid of these A's. And then you'll get nothing. In the next example, we can get rid of all the A's over here and all the A's over here. Then all the B's and all the B's, and then we have CCA, which is 3 characters. So it's a pretty straightforward problem because you're basically deleting all the characters that are equal, and the prefix and the suffix have to be like the same characters. So in order for all the characters to be equal and they have to be the same character, basically your prefix and your suffix has to be like all of one character. So let's take a look at this example. So basically, it's pretty easy. Like you just have some pointers like this. So you have a pointer over here and a pointer over here. And as long as your characters are equal, so like as long as this is equal to this, you can just keep deleting as long as you have that character. Even if you like run over, like let's say this whole thing is B's, you can just keep deleting, and then once this left pointer gets past the right pointer, then you can stop. So what's going to happen here is you're going to delete like all of these B's. You're going to delete all of these B's and then update your pointers. So this pointer will now point to the A, this pointer will point to the A. Now the A's are the same, so we can do this operation again, so we can get rid of the A's and update our pointers. And then we can get rid of the B's because they're still the same character, so we get rid of all of them in just in a loop. Update our pointers. And then we can get rid of the C's. Update our pointers. And then we have a couple more, so we get rid of the B's, update our pointers, and then we can get rid of the C's and update our pointers. And now both pointers will point to one character, so this is like the edge case in this problem. So whenever you have something like ACA, you can get rid of these, but then you can't get rid of this last thing because the prefix and the suffix can't share characters. And that would be, that is the case as long as the thing you're deleting is more than one character. So if you have this like one character left in the middle, you can't do anything. But if you have something like AAA, then you can delete the whole thing because then your prefix can be like this and your suffix can be these two. So as long as basically you don't have like the one character, you can get rid of all of it. So you just keep checking. You just have 2 pointers and you just keep checking if all your characters are the same. You don't have to like delete anything until you actually get to the end. So once you get to the end of where your pointers are, you just like return the length between the 2 pointers. So you don't actually have to like keep a string and delete or anything. That's why it works pretty well. And you do need a linear time solution, so you can't like be like remaking a string anyway. So yeah, so you basically just keep checking for your characters. Are they the same? If they are, you keep deleting. And you also make sure that they don't both point to the exact same character. And by deleting, I just mean keep moving the pointer up. So you just say like, okay, these are the same. So while my left pointer is less than my right pointer and this character is B, I can just keep moving it up. So I'll move it all the way up to here. Then the same thing here. Well, my right pointer is greater than my left, move it all the way down, and so on and so on. You keep doing this. And as soon as the characters aren't equal, you're basically done. So like, let's say this wasn't A, let's say this was like G or something. You can't do anything afterwards. So that it's basically like a greedy solution. Just delete all of the characters you can, and as soon as you hit a mismatch, you're done, and then you just return whatever the substring is, the length of that. So let's take a look at the code. It's pretty easy. So you just have this left and right pointer that are at 0 and then in the string. Then you just keep doing this while the left is less than the right. The reason I do while left is less than right is because I'll basically have 2 cases. So if at the very end, they both point to some like prefix that's more than one character, then what's going to happen here is this left will actually end up over here. Because I say if left is less than or equal to right and the left character is the same, keep moving it up. So your left will be greater than your right at the very end. as long as like the last thing is more than one character. If the last thing is one character, then my loop will break. So then left will equal right. So depending on the end, if my left is greater than right, or it's equal to right. If it's equal to right, that means I had that one character that I couldn't get rid of, so I'm going to return 1. And if left is greater than right, that means the last chunk had more than one character, and we can just delete everything. So, like I said, if left is less than or equal to right, and the character is the same, just keep moving it up. Same thing for the right. And then otherwise, if left is still less than right, but the characters are different, you're done. Like, you can't do anything else, so you just return length of the string, which is just like a sliding window, right? Same kind of length, right minus left plus 1. And then this is just, like I said, just to check if you have that one character left over or not. And we can submit. It's a pretty easy one. So we can talk about time and space and things. So for time, it's O of n, because we just have like a 2-pointer, and space it's O of 1. So like I said, you can't do something like rebuild the string and get rid of a character, because strings are immutable, so that would fail. Because your string is 10 to the 5th characters, so like that would be like an n-squared solution as well, and it would take up space. So ideally, for almost all problems with strings, you want to just use pointers and then get a solution, like only make a substring when you need it. And the only time we need a substring is when we're actually done. Actually, we don't need a substring at all here. We just need a number of characters, so we don't need it at all. But let's say you were asked to return the substring of like what is left over. What you don't want to do is like have a string and be manually deleting, because then that would be n-squared, and it would also be like more space to begin with. So make sure to use pointers and then only get a substring like at the very end when you actually need it. And that's pretty important for string problems. But yeah, it's going to be all for this one. Pretty easy one. Just greedy. Get rid of all the characters you can. And yeah, like I said, the only important thing to recognize is when you do have that extra character left over at the end, you can't delete one character. But as long as you have more than one, you can split it into a prefix and suffix. So it works fine. And yeah, and if you did like this video, please like it and please subscribe to the channel. I think we're almost at 1,000 subs, and I finally got the like YouTube monetization thing, so that's pretty cool. But yeah, I'll see you in the next one. Thanks for watching.